In today's video, we're going to walk through how to set up Ollama to work with AI Server and how to use it from the AI Server API. This will help those looking to set up self-hosted LLM workloads that can be queued to support low traffic to high volume workloads with API key access control built in. AI Server is a self-hosted solution to help orchestrate and centralize integrations with LLMs and other AI services, including those hosted on your own Ollama instances. Since Ollama itself is an OpenAI compatible service, you can call it directly, which is the simplest approach. However, AI Server can also help you manage access control and switching between various LLM backends, including OpenAI, Anthropic, and even OpenRouter, which is a hosted solution to help you find the best price for your model you want to use. Using AI Server lets you mix your workloads between all these services to reduce costs and to enhance your throughput, all while giving you a backend to monitor and control the jobs right from its own web UI. Within AI Server, services that interact with LLMs are called providers, which can be configured during the installation of AI Server for hosted solutions like OpenAI, Anthropic, and OpenRouter. Whereas to integrate with an Ollama instance, you will need to use the built-in AI Server admin UI to configure it. Let's walk through these steps needed to get up and running with your own Ollama instance and AI Server configured together. First, installing Ollama can be done in a few ways, but for ease of management, we're going to use Docker and a simple Docker run command. This command specifies a volume to store the model files we'll be downloading, a port, and a name. Using this method also has other advantages, like making it possible to have multiple Ollama instances running on the same machine but on different ports, and utilizing different GPUs for different collections of models, which can be useful for optimizing your hardware. Using this command will give us an empty Ollama instance listening on the port 11434. To enable the processing of any LLM requests, we are going to need to pull a model from the Ollama library. This can be done via the Ollama CLI, but since it's running in a Docker container, we'll first have to use docker exec, pointing to the name of the container, which in this case is just Ollama. From inside the container on our bash terminal, we can run the command ollama pull Llama 3.1, which will download and make the model available to this running Ollama instance. Once we're ready, we can test the model directly from inside the container as well by running the command ollama run llama 3.1. Provide a prompt and we should see a response start to be generated. Now that we know that our Ollama instance works with the model that we've downloaded, let's set up AI Server with an AI provider pointing to this Ollama instance. We can install AI Server by cloning the repository from GitHub at serverstack/AI-server. Once cloned, we can use the command cat install.sh pipe bash from within the local repository directory. This will kick off a guided installation that runs AI Server as a Docker container locally. This installer enables the ability to add various hosted solutions and optionally set up a comfy UI agent, but for this example, we will just skip these steps and run AI Server by itself. Since both AI Server and Ollama are running in Docker containers locally on the same machine, you'll need to join the Ollama container to the AI Services Docker network so that they can communicate over HTTP, since localhost won't work from the perspective of AI Server. You can do this using the command docker network connect space AI-services space Ollama, where Ollama is the container name that we gave in the docker run command, and the AI services network was created as a part of the AI Server installation script. Once AI Server is running, we can log in using the specified admin password from the installation process and go into the admin UI by clicking on the user at the top right and clicking admin. This is where we can control API key access, chat and media providers, as well as monitor all the processing and queued jobs. Clicking on AI providers on the left-hand menu, we can add our Ollama instance by clicking Add, selecting Ollama, and providing the API URL. It defaults to localhost port 11434, so we'll need to change this to Ollama port 11434, and it will connect and show us our installed model. We can see the Llama 3.1 model that we downloaded earlier at the list at the bottom, because it's querying the Ollama instance asking what models are available. This enables us to control which models can be used through the configured provider and giving you more control over how the specific Ollama instance can be used through AI Server. Saving our new AI provider, we can test it out in the built-in chat UI in AI Server, again to ensure that the integration is working correctly. Now, if you only need a single Ollama server to chat to yourself, going through AI Server likely doesn't make much sense. However, if you need to run larger workloads on specific models and control the API key access and want a way to monitor that workload, integrating with other systems and prevent lock-in with specific API providers, this is where AI Server can be well suited to those needing a self-hosted solution. Next, let's write a simple .NET Console application to integrate with AI Server to show you how the process of automating a task with LLMs using C#. Since AI Server is built using Server Stack services, we can leverage tooling like the node-based getDTOs tool to generate our client data transfer objects, or DTOs, so that we can use it with the Server Stack client of the language of our choice. By running the command npx get-dtos space cs and the path to our running AI server, we will get a generated set of classes in our local directory. And then we can add the Server Stack client NuGet package for the JSON API client to use those DTOs by running .NET add package serverstack.client. This same approach can be used for 11 different languages, and the example usage can be found on the front page of your running AI server as well as the AI server documentation. In this example, we're just going to read for some text files in a folder as the prompt and logging the results to our console output. We are using the JSON API client with the generated DTOs and the OpenAI compatible API to call the endpoint synchronously and output the results. Alternatively, we could use the queued endpoint for the same request. This will return quickly with the details of the background job, and the worker for your Ollama provider will process the job when it is able to do so. The client can then poll for the status of the specific job on the ID that's returned to get the results. Or alternatively, you can use the reply to option to get a web callback to a third running service. This will post the specific endpoint you provided when it's completed along with the results from the job. If your AI server was configured with multiple Ollama instances as providers, as well as API services that support the same models, requests will be spread between the providers by default based on related queue job counts and priority set to the provider. This can be extremely useful for large batch processing where pricing for an open weight model might vary, and cost of temporarily renting GPU time can also change. For example, runpod.io could be used as an Ollama host that you enable and disable when running specific workloads. The advantage and flexibility of AI Server enables self-hosting options to optimize for costs further and avoid integration lock-in by providing a way to control access to different models in a dynamic way. Ollama is a great tool for self-hosting open-weight LLMs with your own hardware to get the most out of your investment, or minimizing the cost on renting GPU time for the most time-sensitive tasks. Well, that's it for this video. If you have any questions or feedback about using Ollama with AI Server, let us know in the comments. And as always, thanks for watching.